Hello students, in this video I will be explaining you the exercise 6.2 sum number 5 onwards. Up to sum number 4 we have already done. Now sum number 5 is in this figure, this DE is parallel to OQ and there is one more line, that is DF line. This DF is parallel to OR and we have to prove that EF. So to prove is the important part. To prove that it is EF. EF is parallel to QR. Please see this part now. So here the solution of this one is, please see, in triangle POQ, this triangle POQ triangle, DE is parallel to OQ. Therefore, now look at this triangle. Now in this triangle, if this line is parallel to this line, then PE upon EQ is equal to PD upon DO. This is by the BPT, the first part. The second part is in triangle POR, what you will find? DF is parallel to OR. So PD upon DO is equal to PF upon FR. This is again by the BPT. Now you see this PD upon DO, PD upon DO. So from 1 and 2. From 1 and 2. What you will find? You will find that PE upon EQ is equal to PF upon FR. See, this part upon this part equals to this part upon this part. So by converse of BPT, what you will find? You will find that this line, that is EF is parallel to QR. So this is the problem where we have used the BPT as well as the converse of BPT. So we have proved that this side is parallel to, this line is parallel to this particular line. I hope this part is clear to you. Next sum. See, dear students, prove that the line drawn through the midpoint of one side of a triangle parallel to other side bisect the third side. So here in this the answer of this problem is, if you study nicely, you will find that DE is parallel to BC. This line is parallel to this line and D is midpoint of AB. Now in triangle ABC, please see, DE is parallel to AB. Therefore, से क्या होगा? AD upon DB is equal to AE upon EC. This is by the BPT. The second part is, because D is midpoint of AB, therefore AD upon DB is equal to 1. This is the second part. Now see, AD upon DB equals to 1. So we'll put this value here. So from 1 and 2, what you will find? 1 equals to AE upon EC. So if you multiply, it is EC equals to AE. Therefore, E will be the midpoint, because the ratio of these two is 1. That is AE upon EC is 1. So if you cross multiply, you will find that this part is equal to this part. So we can say that this line, which is parallel to this line, moving from midpoint, definitely it will bisect the third side, this is the midpoint theorem, converse of midpoint theorem. You have read this theorem in class 9, but there was a very complicated proof of this theorem in the 9th class. Here, with the help of BPT, we can write this in very simplest form. I hope this is clear to you. Now I am taking the next problem, that is problem number 9. Yes, dear students, one of the important sum, ABCD is a trapezium. This line is parallel to this line and the diagonals are intersecting at point O. And we have to prove that AO upon BO equals to CO upon DO. So the first construction is draw OE parallel to AB. So here I am making one parallel line. This line. This line is parallel to this line. Now, in triangle ABD, this EO is parallel to AB. Therefore, what you will find, please see, when this line is parallel to this line, it is DE upon EA is equal to DO upon OB. First one. Then, in triangle ACD, this triangle, here also this EO is parallel to DC parallel to AB. See, this line is parallel to this line. We have done the construction and these two are already parallel. So this line will be parallel to this line also. So what you will find now? AE upon ED is equal to AO upon OC. But here it is DE upon E. So I am changing this DE upon AE is equal to OC upon OA. Now, see the first part and second part. So from 1 and 2, you see this part and this part is equal. So from 1 and 2, from first and second, what you will find? OC upon OA is equal to OD upon OB. So if you interchange, then this term will transfer here and this term will transfer here. So it is OA upon OB equals to CO upon D. So in this way, we can prove this part. If you transfer them, it is OA upon OB and this side OC upon OD. So this is the use of the basic proportionality theorem, that is by the BPT. This is the important part of the BPT here. So I hope this part you understood. There is one more method to solve this problem that I will explain you in the next exercise, which is easier than this method. So now I think the 6.2 exercise is clear to you. There are few sums which I left. You can try these sums and you can practice these sums also with the help of the image which I am sending to you. Thank you.